Hello everyone and welcome back. Today we're discussing Chapter 1, Lesson 7, Solving Absolute Value Equations. So the objective for today is to solve equations in one variable that contain absolute value expressions. So let's go ahead and look at example number 1. It says solving absolute value equations. So we have A here. Now whenever we're dealing with absolute value, we need to understand that absolute value is talking about the distance away from 0. So here, what this is saying is the distance is 4. Well, you can go, if you're at 0, you can go a distance of 4 this way, right? Which would give you 1, 2, 3, 4. So distance 4 that way. That would give you positive 4. Or you can go another way distance. You can go a distance of 4 here in the negative direction. It's still a distance of 4, but you end up at -1, -2, -3, -4. That's where you end up. Okay? So it's this idea of distance can either go this way in the positive direction, or it can go this way in the negative direction. So we have to be thinking about that. So when we have this, the first thing you want to do is you want to isolate that absolute value symbol. This whole thing right here, these absolute value symbols, you want to get that on one side of the equation by itself. And in this example, it's already by itself on this side of the equation. Once it's isolated, then what you do is, because the distance can go in the positive direction, it can go in the negative direction, right? You end up with a positive 4 and a negative 4. Once this is isolated, what you do is you split this into 2 different equations. Now this first example is pretty simple, but it's going to become a little bit more clear when we get into more complicated examples. So we split it in. Now we always leave this exactly the same. Inside, those absolute value symbols remain exactly the same. So we have x, and once we split it in 2, we drop the absolute value symbol. So we no longer have the absolute value symbols. So we have x equals 4, and that is representing the positive 4 here, right? From 0 there, we can go 4 this way, which is a positive 4. Or, okay, we keep this x, drop the absolute value symbols. X can equal, there's 2 options. X can equal a positive 4 here, or if we go 4 units this way, X can equal -4. And those are our 2 answers. X equals 4 and X equals -4. All right, let's go ahead and go to B, problem B. We have 4 multiplied by the absolute value of x plus 2 equals 24. So the first step is always to isolate those absolute value symbols. These right here, we want to get these by itself, okay, on this side of the equation. Well, right now, they're not by itself because there's this 4 multiplied by the absolute value. So we got to get rid of the 4. So we're going to do the inverse operation, right? This is 4 times. Inverse operation of multiplication is division. So we're going to divide this whole thing by 4 to both sides. And what we end up with is the absolute value of x plus 2 equals 24 divided by 4, which is 6. So the question is, have we isolated these absolute value symbols? Is this absolute value symbol the only thing on this side of the equation? And the answer is yes. There's stuff inside, okay, but we just kind of ignore that. All we want to do is get these absolute value symbols by themselves. And we did that, okay? So now that we do that, we split it into 2 equations. Now, this stuff inside the absolute value symbols always stays the same. So this always stays x plus 2, okay? Now this is the thing right here, this is talking about distance. So wherever we are from the absolute value of x plus 2, we can go 6 this way and then we can go 6 in this direction. So when we go in this direction, we're going a positive 6, and when we're going this direction, that would be a negative 6. Okay, so that's where we get our two equations. So this stays the same. That x plus 2 does not change. The stuff inside does not change. It remains the same. And we're going to say equals the positive 6. And then right here, we're going to write this again. And this x plus 2 stays the same. Nothing changes. Except now, it's going to represent going 6 in the negative direction, which would then give us, we would end up with negative 6. Now, once we're here, we have two equations. Here's our first, here's our second, and we just solve them both independently. So now we're going to try to get x by itself. And notice that once we split into those two equations, the absolute value symbols went away. So when we do this process of breaking it into two equations, we no longer need the absolute value symbols. All right? So now we just solve for x. So we want to get x by itself. What's around x? Well, there's a 2. How is it related? Through addition. So we're going to do the inverse operation of addition, which would be subtraction. We're going to subtract by 2 to both sides. That cancels in 0. We're left with x equals 6 minus 2, which is 4. We're going to go over here. We want to get x by itself. We have x plus 2, right? We got to get x, so we got to get rid of the 2. It's related through addition, so we're going to do the inverse operation, which would be subtraction to both sides. That cancels. That becomes 0. We have x equals negative 6 minus 2, which would be negative 8. And there you have it. There's your two answers. X can equal 4, and x can equal negative 8. All right, let's go ahead and try this a couple more times. So let's look at C. So C, the first thing we want to do is isolate those absolute value symbols right here. We want to get these by themselves. Well, on this side of the equation, well, they're not by themselves because there's this minus 3 right here. So we have to get rid of it. We're going to do the inverse operation. So the inverse operation of subtraction would be addition. We're going to add 3 to both sides. We end up with the absolute value of x equals 7. Okay, we have isolated those absolute value symbols. Now it's time to break it into two different equations. Remember, whatever inside, whatever it is, just stays exactly the same. So we're going to have x equals, and this is the part here, a positive 7. And notice that when I broke it into two equations, I no longer write those absolute value symbols. We just have x equals 7. And then x, so this is our x here. X and x stays exactly the same, equals the negative 7. Okay, and that's it. X equals 7, x equals negative 7. Those are the two answers. All right, let's go to D. Okay. We're trying to isolate these absolute value symbols right here. We need to get those by themselves. So are they by themselves? We don't care about this stuff in the inside. We only care about isolating these absolute value symbols. No, they're not. There's a 3 that's multiplied by them. So we need to get rid of this 3. Well, how is the 3 related to them? Well, it's on the outside, and when something's on the outside, that means it's multiplied. So we're going to do the inverse operation of multiplication, which would be to divide by 3 to both sides. 3 divided by 3 is 1. 1 times the absolute value of x plus 7 is just the absolute value of x plus 7. Equals 24 divided by 3 is 8. Now the question is, did we isolate the absolute value symbols? Are they by themselves? Remember, we ignore this stuff inside, and yes, these absolute value symbols are the only thing on this side of the equation, so we did our job. Once we do that, what we do is we split it into two equations. We keep this stuff on the inside exactly how it is. So we have the equation x plus 7, which is exactly like the inside. And remember, this is talking about the distance going in the positive direction, plus 8, and the distance going in the negative direction, which would be negative 8. So we have this x plus 7 equaling a positive 8, and then over here we have the same x plus 7 equaling a negative 8. Now, remember when we go into two equations here, this is our first, this is our second, we drop those absolute value symbols, okay? And then now we just solve for x and figure out what x is. So we want to get x by itself. Right now there's 7. 7's related to x through addition, so we're going to do the inverse operation of addition, which would be subtraction. We're going to subtract by 7 to both sides. That's 0. We end up with x equals 8 minus 7, which is 1. So that's one answer. Then we go over here. We're trying to get x by itself. There's a 7 here, so we have to do the inverse operation of addition, which would be, yes, subtraction. We're going to subtract by 7 to both sides. A positive 7 and a negative 7 cancels out and becomes 0. We're left with x equals negative 8 minus 7, which ends up being negative 15. So those are the two answers right there. X equals 1 and x equals negative 15. So whenever you're dealing with absolute values, you can sometimes have two solutions. Okay, let's look at the other examples here. All right, so we have E and F. How about you try E and F on your own? All right, so go ahead and pause your device. Make sure you write in a pencil. That's always very super duper important. Try E, try F, and then when you get done, press play and we'll go over it. All right, see you in a bit. You can do it, I promise. Okay, we're back. Let's go ahead and discuss E. Let's see how you did. So we have 3 multiplied by the absolute value of x minus 12 equals 18. Okay? So our goal first is to isolate those absolute value symbols. Now there's a lot going on this side of the equation, okay? But that's okay, we can do it. So we have the absolute value is being multiplied by 3, and then there's also this minus 12 over here. So what we're going to do is we're going to get rid of this bit on the outside first by doing the inverse operation of subtraction, which would be addition. We're going to add 12 to both sides. Okay, negative 12, positive 12 cancel out. I am left with 3 multiplied by the absolute value of x equals 18 plus 12. 2 plus 8 is 0. Carry the 1. 1 plus 2. 1 plus 1 is 2 plus another 1 is 3. Okay, and remember what we're doing. We're trying to isolate those absolute value symbols. We don't care what's inside at this moment. And it's not by itself. There's a 3. Well, how's the 3 related? Through multiplication, right? So we're going to do the inverse operation of multiplication, which would be division. We're going to divide by 3 to both sides. When we do that, we get 3 divided by 3, which is 1. 1 times the absolute value of x is just the absolute value of x, equals 30 divided by 3, which is 10. So now we have isolated those absolute value symbols. So what we're going to do, it's time to split it into two equations. We're going to take whatever's inside, and now it's just x, and that's okay. We're going to write that just how it is. Here and here, really, it's just the same thing. Okay, you write it twice. And then that's going to equal, and notice that when we did the two equations, those absolute value symbols drop. This is going to equal a positive 10 here. Remember, we're going to go 10 this way, which will lead us at positive 10, and then we're going to go 10 the other way, which would lead us to negative 10, which is right here. Okay, and there's our two answers. X equals 10 and x equals negative 10. So if you got that one right, great job. Let's go ahead and look at F and see how you did. Now remember, the first thing we need to do is isolate those absolute value symbols. right here. And to get those by themselves. So to do that, the only thing that's on this side is the subtracting by 6. So we're going to do the inverse operation of subtraction, which would be addition. We're going to add 6 to both sides. We end up with the absolute value of x minus 3 equals 2 plus 6, which is 8. Now we have those absolute value symbols. We've isolated it. It's the only thing on that side of the equation. So now we know it's time to break it into 2 equations. When we break it into 2 equations, we write this inside exactly how it is. So we write it twice. X minus 3 here, x minus 3 here. Okay, nothing changes. The stuff on the inside stays exactly the same. But what does change is this 8. Remember, because absolute value, it's talking about going 8 in this direction, which would be a positive 8, and also going 8 in this direction, which would be a negative 8. So we're going to go x minus 3 equals positive 8, and x minus 3 equals negative 8. Once we have our 2 equations, remember when we do that process, we drop those absolute value symbols, so we no longer write those. And then we just get x by itself. All right, so we solve. Okay, there is x by itself? No, there's minus 3, so we're going to do the inverse operation of subtraction, which would be addition. We're going to add 3 to both sides. That cancels. What we're left with is x equals 8 plus 3, which is 11. And boom, there you got it. That's one of the solutions. And then we're going to do the same thing over here with this second equation. We want to get x by itself. Right now it's being subtracted by 3. So we're going to do the inverse operation of subtraction, which would be addition to both sides. That cancels out and becomes 0. We're left with x equals negative 8 plus 3, which would end up being negative 5. And there you have it. There's your 2 solutions. So if you got that right, great job, and we'll see you in a little bit for example 2.